any mistake that you made. So it'll have some feedback for you. So that way you can see what you did wrong. I'll upload the exam solution later on today. So that way you can kind of compare and contrast what you did on the exam and compare it to the correct solution. And for the exam was out of 55 points. So if you want to figure out what your grade was on the exam, all you have to do, you get your points. So say if you got like 45, get 45 and then you divide it by 55. And you do kind of want to see a percentage higher than 70% because 70% or higher mean that you pass. Anything below 70% mean that you didn't pass. So you do kind of want to see 0.70 or above. All right. Any question in regard to that before we get started with today's lecture? All right. So for today's lecture is going to be day 10 and day 11 lecture. So we're going to go over day 10 lecture right now. So let me share my path. All right, so everybody should be seeing a screen that says day 10 binomial experiment. So today what we're gonna go ahead and do, we're gonna go ahead and do something called the binomial experiment. So a binomial experiment, well, for a binomial experiment, there are some conditions that must be met in order for it to classify as a binomial experiment. So we're gonna go over where it says definition. All right. So if you look at the first part of the definition where it says A, it says the experiment is repeated for a fixed number of trials where each trial is independent of another trial. So what that's reflecting is saying that they have to tell you how many times they're gonna do the experiment. So let's take the scenario of like flipping a coin. They can't just tell you we're gonna flip the coin until we get 20 heads. In order for it to be considered binomial, they have to tell you we're gonna flip the coin 40 times or 50 times or just 5 times. So they have to tell you how many times are they gonna flip the coin. So what we call that N. Sweet, let's mute everybody. All right, so they have to tell you your trial. So we're gonna call that N. So once we know pretty much, if they tell us they do it like N many times, we know that it will be considered a binomial experiment. So the next condition that we have is part B. It says there are only 2 possible outcomes of interest for each trial. So the outcome should be classified as either a success or classified as a failure. So since this is called binomial, bi means essentially 2. So there should only be 2 different outcomes. So one of them, we're gonna call them the success outcome. The other one, we're gonna call it a failure outcome. So let's go back to the scenario about flipping a coin. So say I'm only looking for how many times does the coin land on heads. So in that case scenario, we're gonna say heads is a success because that's what we're looking to occur. And we're gonna say a failure will be that it land on tails. Cool. So you always want to classify them as 2 categories. So you should have head and then you should have tail. Heads will be considered success, tails will be considered a failure. All right. Any question for B and C? All right, last one, the probability of a success, P of S, is the same for each trial. The random variable X counts the number of successful trial. So P of S is always the same. So kind of think about it like when you flip a coin. When we flip the coin the first time around, the probability that I land on heads is 1 out of 2. The probability that the coin will land on head if I flip it a second time around is still going to be 1 out of 2. So each time we flip the coin, that probability should remain the same. So if I flip it in the 1,000th time, so that 1,000 times the probability that I would land on heads should still remain to be 1 out of 2 or 50%. So that wouldn't mean when I said they're independent trial. Independent trial just mean that one event doesn't influence the probability of the other event. Because if you kind of remember the conditional probability, one event influences the other event. But if they're independent, the probability of the first event shouldn't interfere with the probability of the second event occurring. Cool. So you have probability of S, which we commonly just say as P. And then we have probability of failure, which will be 1 minus P. All right, so let's go down. All right, so if you look right here, pretty much I put all of the labels so that way you kind of know how to label it. So N is the number of time a trial is repeated. So if you remember, that's your experiment. P is the probability of success. Q is the probability of failure. And the way that you get the probability of failure, you get P and you do 1 minus that. And remember, this kind of go back to it being a binomial distribution. Since you only have 2 options, pretty much if one of the probability is like 0.40, that means the other one, if you want to get the probability of failure, you do 1 minus 0.40 and you get 0.60. And lastly, X represents the number, the random variable represent a count of the number of success in a trial. So X could be 0, 1, 2, 3, 4, all the way to n many. All right. Any questions so far in regard to that? All right, so let's scroll on down. All right. So for the next problem, all we're gonna do, we're gonna just say if these events are a binomial distribution or are they not a binomial distribution. If it is, specify the value of n, p, q, and list possible value of the random variable x. If it's not, explain why. All right, so let's do A. So it says a certain surgical procedure had an 85% chance of success. A doctor performed the procedure on 8 patients. The random variable represents the number of successful surgery. All right, so let's first look for N. So for this one, did they tell me how many times are they gonna perform this surgery?
Yes, on 8 patients.
Cool, yeah. So they tell us how many times they're gonna perform this experiment. So they tell us they're gonna perform this experiment on a patient. So we know N is equal to 8. All right, so do they tell us the probability of this event occurring? So do they tell us the probability that the surgery is a success?
85%.
Yeah, so they do. So they tell us is 85%. All right, so if we know 85% of the time is a success, if I wanted to find the failure, you do 1 minus 0.85, which is equal to 0.15. Cool. So if you look at that, we got the probability of success and we got the probability of failure. I mislabeled that. That should be Q. And if you look right here, X represents the number of successful surgeries. So X is however many successful surgery that we have. So the last thing we have to kind of check to see if the events are independent. So say we have the first surgery, what are the chances that the first surgery is successful? Well, it should be 85%. So what about the second surgery? So now they're going to do the second surgery. Does that probability changes or does it remain the same at 85%? So would it remain the same or does it change? Well, if you look at the problem, most likely it's going to remain the same because each person is an independent individual. Like, it doesn't really matter if the first one is successful. It doesn't make it more likely that the second one is successful or less likely that it's successful. So we're going to say they're independent. So we're going to say this is a binomial distribution. All right, and that's it for A. So for A will be considered a binomial distribution. So let's do B. So for B, it's a jar containing 5 red marble, 9 blue marble, and 6 green marble. You randomly select the 3 marble from the jar without replacement. The random variable represents the number of red marble. All right, so let's see. For this one, do they tell us how many times are they gonna pick a marble? Well, if you look right here, they tell us exactly that they're gonna pick 3 marbles. So we know n. So n is 3. Now let's look to see what are they looking for. So what are they looking for?
Red marbles.
Yeah, so that's our success. So they want to see the probability represent the number of red marble. So if you look at the problem, they tell us they have 5 red marble. So they have 5 red marble, 9 blue marble, and 6 green marble. So if I want to figure out what to divide it by, you just have to add those numbers.
And that's 20.
Yeah, so you get 20. All right, so then if I want a failure in this case scenario would be that you don't get a red marble. So if the probability that I get a red marble is 5 out of 20, the probability that I don't get a red marble will be 15 out of 20. All right, so lastly, what we want to go ahead and do, we want to check to see if they are independent of each other. So say if I'm looking for the probability of getting a red marble, and then I want the next one to be a red marble, and I want the next one to be a red marble. I want to make sure that all of these events are independent from each other. So the first time I get a red marble, it should be 5 out of 20. What about the second time I'm trying to get a red marble? Is it still going to be 5 out of 20 or is it going to be something different?
Be 4 out of 19.
It'll be 4 out of 19, which is something different. Because if you look right here, it says without replacement. Without replacement means once you select that marble or that red marble from the jar, you essentially can't pick that marble anymore. So if you look at it, we have one less. So our probability change. So since our probability change, we're going to say not independent. So since it's not independent, we're going to say not binomial. Great. And that's it for B. So for B, it's not a binomial distribution because the events are not independent from each other. If they were to be independent from each other, the probability wouldn't have changed. So the first one should have been 5 out of 20. The second one should have been 5 out of 20. The third one should have been 5 out of 20. But in this case scenario, since we're doing it without replacement, each time we get a marble, the probability is constantly changing. All right, so let's do the final one. So let's do C. So for CSUDH, you take a multiple choice quiz that consists of 10 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly, geez, so you randomly guess the answer to each question. The random variable represents the number of correct answer. All right, so first thing first, let's see how many trial do we have. So a trial is every time you guess. So for this one, all you have to do for the trial is see how many questions do we have to guess from. So how many questions do we have to guess from?
10.
4.
Well, if you look here, we have 10 questions. So we say n is equal to 10 because we're guessing on 10 questions. So now let's get what is the probability that we guess a question correct. So right now we're looking at a singular question. What we want to see if we just guess if we just guess on that question, what's the probability we actually guess correct. So right now we're gonna find the probability of success. All right, so when I'm guessing on this one question, so you think about it, you're guessing, so you have a B, a C, and a D. So how many options do I have to guess on?
4.
Yeah, so you have 4. So that's what you divide it by. Okay, you have 4 options to choose from. So, of those 4 options, how many of them are correct? Well, if you look at a multiple choice quiz or a multiple choice test, whatever it is, if you have 4 options, only one of those options is going to be correct. So the probability that you randomly guess correct is 1 out of 4. So let's see the probability of failure. So the probability of failure will it be that you guess incorrect. So if the probability that you guess correct is 1 out of 4, the probability that you pretty much guess incorrect will be the complement of that, or 1 minus 1 over 4, which is equal to 3 over 4. All right. Any questions so far? I got 3 over 4. All right, so up next we're gonna do, we're gonna check to see if they're independent. So remember, if they're independent, that means that from question 1 to question 2, all the way to question 10, all of them should have the same probability. So say you have here question 1. All right, so for question 1, what's the probability that I guess question 1 correct, if I'm just guessing?
1 out of 4.
Yeah, 1 out of 4 good. All right, what is the probability that I guess question 2 correct?
1 out of 4.
1 out.
Yeah, 1 out of 4. So lastly, what is the probability that I guess question 3 correct? Well, it will be 1 out of 4. So if you look at this, the probability of success doesn't change. Your probability of success is the same as in the first one, all the way to the third one, all the way to the 10th one. So if you're guessing, you have a 1 in 4 shot at being able to pretty much guess this correct. All right. So for this one will be considered binomial. All right, and that's it for letter C. Any question for letter C? All right, so that's how you could tell if it's a binomial. So if it's a binomial, you should have a set amount of trial. You should have a probability of success and a probability of failure, and all of the events should be independent from each other. So up next, we're gonna get into the formula. All right. So for the formula, we're actually going to use this, and we're going to get this with class calc. So to get NCX, we're going to use class calc. So for class calc, well, sorry, for NCX, do you tell us how many groupings do we have? So what this is going to tell us, it's going to tell us like how many different ways can we get X many success. So let's go back to the one about the multiple choice quiz. So say we have 10 questions and I want to get one correct. So we got 10 questions, we want to get 10 correct. So what the NCX, what that portion is going to do, it's going to tell me how many different ways can I get one question correct out of a quiz or a test that had 10 questions. So like one way will be you could get the first one correct, but then you get everything else incorrect. So that's one way that you could get one correct answer and everything else is incorrect. But that's not the only way that you could get one correct question, because now what could happen, you could get the first one incorrect and then you could get the second one correct and everything else you get incorrect. Or what you could do, you could get the first one incorrect, you could get the second one incorrect, you could get the third one correct, and then everything else you get incorrect. Or what could happen, you could get the first one incorrect, the third one incorrect, and then you get the fourth one correct, and then everything else is incorrect. Or you could get the first one incorrect, second one incorrect, third one incorrect, fourth one incorrect, and then you get the fifth one correct, and incorrect, incorrect, incorrect. And that's the incorrect here. So let me put on all the other options. One, two, three, four, five. Cool. All right, so those are all the different ways where you could get one question correct and then everything else you get incorrect. So if you look at how many total outcomes do I have, if you count all of these outcomes, we have 10 outcomes. But instead of you having to do all of that work, what we're going to do, we're going to use the NCX option in class count. So I'm going to show you how to use the NCX option in class count. Cool. All right. So for this one, you go to stats, and it should be under basic. So if you look right here where it says NCR, R actually represent X, so don't get that confused. So if you look right here, first thing I want you to do is enter n. N is 10. So then the second thing that I want you to do, I want you to enter x. X is 1. So if you look right here, it gives you 10. Wait. And that's your final answer. So 10 will be your final answer. But we kind of already knew that because we had already listed out all of the different options. But instead of you having to list out all of the different options, just use NCR and class cal. So that way you could get the answer. All right. So any question in regard to NCX? All right. So let's go over the rest of the formula. So if you look right here, here you go. P is a probability of success. And you want to take this to the x power, which x is representing how many success do you want. So you go P, the probability of success, and then you tell it to the whatever power, how many of those success do you want? And then you have Q, which is the probability of failure. And then you do n minus x, which this is going to tell you how many failures. What do you put fails? And then all you have to do is multiply all three of those numbers out, and that way you could get the answer. All right. Everybody go for that formula. All right, so let's go ahead and do this example. So for this one, it says microfracture knee surgery had a 75% chance of success on patient with degenerating knees. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So let's go ahead and find N. Let's find what P is. Let's find what Q is. And let's find what X is. So for this one, what will be my N? How many patients do we have?
3.
Yeah, so you have 3. All right, so if you look at it, we want to find the probability of having a successful surgery. So that means P, which is the probability of success, will be, what is the probability the surgery is a success? So what's the probability that the surgery is a success?
75%.
Yeah, 75%. So if 75% of the time it's a success, so Q will be how many times do we have a failure? So how many times is it not a success? So that will be 1 minus 0.75, which is 0.25. So lastly, what we want to do, we want to do X. So X is how many success do we want? So for this one, how many success do we want?
2.
Yeah, 2. All right, so if I put this into the formula will read as 3C2 multiplied by P, which is 0.75 to the X power, which is 2. And then you get Q, which is 0.25, and you take that to the N, which is 3 minus 2. All right. Any question how I got 3C2.75 to the second power times 0.25 to the third minus 2? Okay, so I'm going to go over to class count, and I'm going to calculate this in class count. So let's go over to class count. All right, so I'm going to go over here, delete this. So you put 3, you put 2, and if you look right here, you get 3. So for this portion, you put 3. So you get 3. So the 3 represents that there's 3 different ways where you can have 2 successful surgery and 1 failure. Because if you kind of think about it, You could have the first two are a success, and then the last patient is a failure. Or you could have the first one is a success, the second one is a failure, and the third is a success. Or lastly, you could have the first one is a failure, second one is a success, and the third one is a success. So that's where the three come from. The three come from where there's only three different ways where you can have two success and one failure. All right, so then you still have 0.75 to the second power. And then you have 0.25. If you look at 3 minus 2, 3 minus 2 is 1. All right, so far I had 3. Multiply by 0.75 to the second power. Multiply by 0.25 to the 1 power. But if you kind of look at it, if you have 0.25 to the 1 power, you can just rewrite that as 3 times 0.75 to the second power times 0.25. So you can drop that 1. All right, so up next, what I'm going to go ahead and do, I'm going to go over to class calc, and I'm going to do this calculation, and that should be it for that. All right, so in class calc, we're going to say 3, and then you're going to say multiply, and then if you want, you can use parentheses, and you can say 0.75. And for this one, you do need the power button, but since we're doing to the second power, if you look right here, let's see, annotation, spotlight. If you look right here, I'm going to use a to the second power. So that will make it 0.75 to the second power. Then we can close parenthesis. And then you can just say multiply by 0.25. Great. And if you look at it, you get your probability to be 0.4219. So you get 0.4219, and that's your final answer. Any question in regard to how I found that probability? All right, so let me go ahead and switch back to my notes, and that way we could try out a different problem. All right, so I accidentally repeated this problem. So we're not gonna do this one in green, we're gonna do the one in red. All right, so this one says, in a survey, they found out that 58% of children get car sick. If 5 children are to be randomly selected, what is the probability that 2 of them get car sick? All right, so let's go ahead and let's list out all of these important things. So let's get N, let's get P. Well, I accidentally put Q, but you know what I mean. So let's get P, and then let's get X. So for this one, how many children did I get?
5.
2.
Yeah, 5. So we put 5. All right, so what's the probability that a kid would get car sick?
58%.
8%.
Yeah, 0.58. So if the probability a child will get car sick is 0.58, Q will be the probability that they don't get car sick. So that will be 0.42. On the top, I'll put right here 1 minus 0.58, in case you need that little reminder. So we found our P and we found our Q. So just remember, P and Q, when you add them, should always add up to 1. If you add P and Q, if it doesn't add up to 1, you're probably most likely doing something wrong. All right, so for X, how many of these 5 children do we want to get car sick?
2.
Yeah, 2. So we put x is equal to 2. So I'm going to go ahead and write this out. So we're going to say phi C2, and we're going to multiply this by the probability of P, which is 0.58. And we're going to put this to the x power, which is 2. And then we're going to multiply this out by 0.42 to the n, which is 5 minus 2 power. All right, so let me go ahead and just clean this up a little bit. So this will be 5c2 multiplied by 0.58 squared multiplied by 0.42. If you work this out, if you do 5 minus 2, you're just going to get 3. All right. So up next, we're going to go ahead and do this in class calc. So I'm going to find this, 5c2. So let's do that in class calc. So we'll say stats, we'll go NCR, and we'll go 5c2. So if you look at that, it's just 10 different ways. So we'll put 10 multiply by 0.58 to the second power, multiply by 0.42 to the third power. All right, so NCR of 5 and 2 gave us 10. So they're telling you there are 10 different ways where you can have 2 success, so 2 children getting car sick, and the other 3 children not getting car sick. All right, so I'm gonna go back to my notes. For that way you can see essentially how I enter it. All right, so you get 10 multiplied by 0.58 squared multiplied by 0.42 to the third power. All right, so up next, what you're gonna go ahead and do, you're just gonna go ahead and do that on class calc. So I'm gonna go back to class calc just to finish this off. So on class calc, we'll say 10. And then we'll say we'll multiply. And we're multiplying this by 0.58. So this one you want to be careful because you want to do it to the second power. So you want to use a to the second. Cool. And then what you want to do, you want to multiply that by 0.42. So for this one, since it's to the third power, you want to use a to the n power. So you use this one and you do it to the third power. Sweet. All right, and that's your answer. So you get 0.2492. All right, and that's it for that second problem for binomial. Any question for that problem for binomial? All right, so let's go back to the notes. All right, so up next, we're gonna learn the definition of binomial probability distribution. So for the binomial probability distribution, it lists the possible value of X with the corresponding probability for each. So let's kind of go back to the problem for the car sick children. So if I want to do binomial probability distribution, you're gonna have your X and you're gonna have your P of X. So with the X value, what you have to do, you have to list out all possible outcomes that could occur. So going back to the problem for the car sick children, what's the lowest amount of children that could get car sick?
0.
Yeah, 0. Perfect. What's the highest possible amount of children that could get car sick from our trial?
5.
Yeah. So you want to go 0 to 5. So looking for us, we already found the probability of 2, which is 0.2492. 0.2492. So what we're going to go ahead and do, we're going to go ahead and just do everything else. So we're going to go ahead and do the probability that x is equal to 0. Because right now we're going to try to fill out this one over here. So the way that we're going to do that is, well, we just have to do it. So we're going to do 5, C, and in this case, if you look at it, x is 0, so you want to put 0 right here. So then you multiply this by the probability of success, so the probability that the child does get car sick, which is 0.58. And in this case scenario, how many children do we want to get car sick?
0.
Yeah, 0. So you put this to the 0 power. So then you multiply this by the probability that they do not get car sick. And for this one, you have to do n minus x. So you have to do 5 minus 0. But if I do 5 minus 0, what's 5 minus 0?
5.
Yeah, 5, good. All right, everybody good? I got 5C0 multiplied by 0.58 to the 0 power multiplied by 0.42 to the 5th power. Sweet.
Yes, sir.
All right, so let's go back to this calculator. All right, so I'm gonna clear all of this out because again, kind of messy. So what I'm gonna do everything in one shot. So I'm gonna do NCR. I'm gonna say 5, comma 0. I'm gonna close it, and then I'm gonna say we're gonna multiply this by the probability of success, which is 0.58. And we want to do this to a to the n power, and you want to put 0. Then what you want to do, you want to go ahead and multiply this out by 0.42. And for this one, you want to do it to the 5th power. So you go once again to a to the n, and you want to put to the 5th power. All right. So if you look at that one, you get 0.0131. All right. Any question how I got that first one? All right, so let's go back to the notes and let's set up the problem for the next one. How did Python come into play? All right, so we're done with this one. Up next, what we're gonna do, we're gonna do this one over here. So we're doing x is equal to 1. So we're gonna say probability that x is equal to 1 is equal to 5c. So instead of me wanting 0 children to get car sick, now I want one person or one child to get car sick. And then you multiply that by 0.58 to the 1 power. Remember, we want one child to get car sick. And then you multiply that by 0.42. So for this one, you technically don't really have to do the n minus x. You could logically just do it. So if you want one kid out of the 5 to get car sick, how many kids do you not want to get car sick? Well, that should be 4, because if one of them get car sick, the other 4 don't get car sick. So you can put this to the 4th power. So let's see, what do we get with that? So I'm gonna do, any questions so far for the setup? All right, so let's go back to class time. Sweet. So in class calc, what we could do, we could go back to stats, we could go back to NCR. So we could do 5, comma 1 this time around. And then we can multiply that by 0.58. And if you want, you can put to the 1 power. And then you multiply that by 0.42. And remember, this one we said it's going to be to the 4th power. So we do it to the 4th power. So if you look at that, you get 0.0902. So 0.0902. All right, so that's our second answer. So that one, x is equal to 1. So let's go ahead and go on to the next one. All right, so we're all done with this one. We already did x is equal to 2, so now we're gonna do x is equal to 3. So for probability that x is equal to 3, we're gonna say 5C3 multiply by 0.58. And which power should I do the 0.58 to?
3.
Yeah, 3. And you multiply this by 0.42. So remember, if I want 3 success, that means I'm going to want 2 failure because they have to add up to 5. So we're going to do 0.42 to the 2nd power. So now I'm going to go back to class calc, and I'm going to go ahead and do this one in class calc. Cool. All right. So if you kind of want to just do this a little bit faster, you can actually just go back to the one you already did and just edit it. So you could just say this is a 3. This it shouldn't be to the 1 power. It should be to the 3rd power. And then right here where it says 0.42, this should be to the 2nd power. And that's our answer for when x is equal to 3. So you get 0.3442. 0.3442. Right. Any question for that? Well, that last problem? All right, so we got 2 more to go. All right, so if you look now, we're gonna do probability that x is equal to 4. So the probability that x is equal to 4 is equal to 5C4 multiplied by 0.58. And for this one, it should be to the 4th power. They say 4 multiply by 0.42. So if I want 4 kids to get car sick, that means there's only 1 kid that doesn't get car sick. They did it to the 1 power. Cool. So that's our formula. Any question how I got that formula? All right. So let's go back to class calc and let's work that out. Right. So once again, I'm gonna just edit this one. So we put it to the 4th. You put this to the 4th. You put this to the 1. And you get 0.2376. So you get 0.2376. All right, so let's do the last one. So the last one is going to be when we have probability that x is equal to 5. So the probability that x is equal to 5 means that we want all 5 of the 5 kids to get car sick. So if all 5 of the kids get car sick, that means none of them don't get car sick. So we're going to say 5C5 multiplied by 0.58 to the 5th power multiplied by 0.42, and none of them get car sick. So for this one, we want all 5 of them to get car sick. So we're going to do 5C5. So we have 5 children. and we want all 5 of those children to get car sick. Then you do 0.58 to the 5th power because we want all 5 of them to get car sick. And for this one, we do 0.42 to the 0 power because we don't want any of them to not get car sick. All right, so then we go over here to class calc. We'll finish this off. So right here, we'll change this to a 5. You change this to a 5. You change this to a 0. And that's your final answer. So you get 0.0656. So 0.0656. All right, and that's your final answer. All right, so this is what we call a binomial probability distribution. So a binomial probability distribution, you list out all of the possible x value that you could possibly have, but you also put the corresponding probability for each one of those x values. So if I wanted to find what's the probability that 4 kids get car sick, well, we already found that to be 0.2376. So you're essentially just listing all of them out. All right. Any question in regards to a binomial probability distribution? All right. So if you kind of look at it, it's kind of like a lot of work to do yet to get all of these distribution. So there is a way in class calc where you can actually get all of this. So let me show you how to do that in class calc. So this is a shortcut way. So in a test or in a quiz, if it doesn't say show work, just do it this way. But if it does say show work, you want to show this and then just multiply it out. So let's go to stats. Right now you're going to go to, I think it should be advanced, but I might be wrong. Yeah, I'm wrong. Go to distribution. So once you go to distribution, if you look at it, it says the normal distribution, the t distribution, and then right here you have the binomial distribution. So you click on binomial distribution. So if you look right here, it wants the n and it wants the p. So for the last problem that we did, the n with how many children did we randomly select? So we randomly selected 5. If you remember, P was the probability that that child get car sick. They put 0.58. Everybody good on 5 and 0.58 for binomial distribution? All right, yes. So right now, don't worry about the CDF or PDF. Just worry about this magnifying glass. So you want to click on this magnifying glass. So if you look at this magnifying glass, it essentially shows you everything. So if you click right here, you see how it says 0, 0.013? So with that, it actually gave me when x is equal to 0, p of x is equal to 0.013. So that's what this is giving me. So if I go to the second bar now, if I go over here to the second bar, you see how it says 1, 0.09? So that 1, 0.09 means x is equal to 1. So the probability of that x is equal to 0.09. So if I go to the next one, if you look at it, it gave me 2, 0.249. So that's telling me for x is equal to 2, the probability of that occurring is 0.249. If you go here for 3, it says 3, 0.344. So that's saying if x is equal to 3, the probability of that occurring is 0.344. And then if you go here 4, if you go here 5, it'll give you all of that probability. All right. So that's how you can get the probability of a binomial distribution with class count. Any question on how to do that?
No.
All right, sweet. So let's go back to the notes. All right. So right here's a binomial probability distribution for microfracture knee surgery. N is equal to 3, P is equal to 3 over 4. So it said use the binomial probability formula to find the probability of each X. Well, for this one, what we're gonna do, we're gonna do this in class count because like it's a lot of work. Like if I ask you to show work, it's gonna be like find the probability X is equal to 1 or find the probability that X is equal to 2. But anytime you have to find like multiple value, you just want to use class count to kind of get the answer. So right now what I'm going to do, I'm going to double check these answers by using class count. So let's go back to class count. Let me erase all of this. So in case you forgot how to get there, you go to stats, you go to distribution, and you go to binomial. For the problem that we just last saw, if you look at it, they gave me n is equal to 3. And then they tell me P is equal to 3 out of 4. So if you want, you can put 3 out of 4. Class count will be able to do that. And then you just make sure that you put the magnifying glass. Too many things on my screen. All right. So if you look right here, for the first one, it says when X is equal to 0, you get 0.016. So if you have your notes, that's what we have for when X is equal to 0. If you go into the next one, when X is equal to 1, you have that for X is equal to 1 is equal to 0.4141. If you go right here, when X is equal to 2, you get 0.422. And when X is equal to 3, once again, you get 0.422. So if you look at these, all of these match up with what's on the table. And that's it. Any question for that last one?
No.
All right. So let's go on to the next problem. All right. So what I want you to do, I want you to create a binomial distribution for this next problem. So I'll get it started for you. I'll create this for you so that way you know what are you looking for. So you have X, you have P of X. All right. So what I want you to do, I want you to take a couple of minutes and do this following problem. So I want you to have the probability filled out for this next problem. So try practicing on this so far. If you get stuck or if you have any question, you could either put it on the chat or if you want, you private message me so that way I could just answer your question in privacy. But try working on this problem right now so you get used to how to do binomial distribution with class count. Because something like this, like you want to use class calc because you don't want to be doing these individual probability by hand. So, all right, so take a minute and do that right now. All right, so let's try doing this one. So for the first one, what did we get for the answer for the first one? If you want, you can put it in the chat. So what do we get for when x is equal to 0?
I got 0.0023.
0.0023. Cool. All right, what about when x is equal to 1? What do we get?
I got 0.2228.
Do you miss a 0 in there, Irvin? Okay, you said 0.228 or 0.022?
It's 0.0228 or 22.
0.022.
I think I did miss the 0. My bad.
No, you're good. All right, so then if you do x is equal to 2, x is equal to 2, you get 0.092. If you do when x is equal to 3, you get 0.212. When x is equal to 4, you get 0.293. when x is equal to 5, you get 0.243. When x is equal to 6, you get 0.112. And lastly, when x is equal to 7, you should get 0.022. And that's it for that one. Cool. All right, so you should be able to do this with the calculator. So you do want to get used to the calculator for that way for a test or for a quiz, you should be able to do this easily versus fumbling around having to do this. Like this should be something that should be pretty easy to do. All right, so let's go ahead and scroll on down. Yeah. Here, let me check out something. Let me check out your activity for today. Cool. All right, so what we're gonna actually do, we're gonna stop right there for this lecture. And what we're gonna do, we're gonna get into the breakout room for that way you can work on activity number 12. So right now we're gonna be working on activity number 12. Also, I already uploaded all of the answer for the activity. Well, for any foreseeable activity. Let me actually get out of here. So let me show you where those are. For that way you can always double check your answer. So one thing that you should kind of notice pretty much after exam 2, all of the material for exam number 3 is already up and ready to go. So you do kind of want to get used to that. So for the homework for today, you actually want to go right here where it says chapter 4, discrete random variable. So if you click right here, click on homework on 4.3. Here is the homework for binomial distribution. So this is where you want to go for the binomial distribution homework. So for today's activity, you want to go right there. You want to go right here where it says activity 12 and 13. So you'll find today's activity over here where it says activity 12. Cool. And lastly, in order to find the solution, so cool. If you go right here where it says activity, so if you look right here, activity number 12, activity number 13, all the way through activity number 19 is already posted. So that way, if there's a question that you didn't quite understand, you check the activity so that way you know that you understand it, because that's where the solutions are there for you to make sure that you understand like what you're doing. So try doing it on your own, but if you get stuck, just go to the solution for that way you can double check your answer. No, you don't have a quiz today. You're gonna have a quiz tomorrow. Cool. And also if you want to check your grade, if you look at Canvas, if you go to grade, you do want to go right here and it'll tell you your grade should be all the way in the bottom. Let me see. Oh, sorry. It should be, well, in mine it's all the way in the top because it says overall grade in class. So if you go to overall grade in class, that should tell you what your overall grade in the class is. So speaking about overall grade, if you feel like you want to drop the class, the deadline to drop the class is going to be Wednesday at 3 p.m. So if you do want to drop the class, the way that you're going to be able to drop the class, all you have to do is just send me an email, and that way I'll send the email to admission for that way they could be able to drop you for this class. But if you feel like this class is a little bit too fast or it's getting harder, you might want to shoot me an email telling me that you want to drop the class. Like if you're at 70% or higher, you definitely shouldn't drop the class because you're most likely going to pass the class. But I'm speaking for student probably like below 60%, you might want to consider dropping the class because if you're at below 60% right now, it's going to be pretty hard to kind of jump from 60% to 70% because the material is only going to get harder. So if you do feel like the class is a little bit too tough on you and you feel like you might want to drop the class, just shoot me an email and that way I'll send it over to admission for that way they can be able to drop you from the class. All right, so right now what I'm gonna go ahead and do, I'm gonna go ahead and just set you up and put you in the breakout room for you to just start working on this, on this activity. So let's do breakout room. Thank you. That's right.